let us discuss this data or a hypothesis problem representing, we have 15 sample values: 12.421, 12.641, 12.832, 12.941, 13.105, 13.928, 12.814, 11.618, 13.625, 13.216, 14.121, 10.363, 10.912, 10.361, 10.325. They may be in units of second. They may represent the finishing time of a 100-meter race of 15 athletes. In that case, the last person is going to take the prize. Or we may represent this as a absorption level of a particular drug in a particular sample of blood. Whatever be it, we are to test a hypothesis in which we would like to test the null hypothesis H naught, which states that the standard deviation of this sample is 1.151. This is our problem. And when we want to test this hypothesis against any alternate hypothesis where sigma is greater than any other value of 1.151. So, our null hypothesis is that these 15 sample values, which we consider to be normally distributed, has a standard deviation 1.151. So, I have done the calculation. It is very straightforward way. We want to find out the mean, and we have shifted the origin to 11.618. You may have take any other values here and calculate the corresponding xi's, the values of xi, and then corresponding value of xi squares, and add them up. If we add these xi, it gives 11.007, and if we divide by the n, it becomes, x bar becomes 0.734. So, actual mean is 0.734 plus 11.618, which is 12.352. This is not relevant here. What is relevant here is a square, and a square is, we know that the formula is 1 by 15 summation xi square minus x bar square, and this turns out to be 1.42. I think it is visible. It comes out to be 1.42. I think it is visible. So, we are to test this hypothesis. And what is our degrees of freedom? Since this is 15 values are there, so our degrees of freedom is 14. 15 minus 1, it is 14. This is the degree of freedom. And our null hypothesis is sigma equal to sigma naught, that is the standard deviation is 1.151. And we tend to use this chi-square. Test statistics is chi-square. So, we would like to calculate this. This n represents 15, and we want to calculate this value using a square as 1.42 and sigma naught square as 1.151. So, it turns out to be 15 into 'So, this is a more or less straightforward calculation. The basic idea behind this hypothesis test is that we have to find out the critical region, and for that matter you should learn how to find the value of the critical region at a particular confidence level. Say we want to find it at 5% level of significance. Okay, fairly simple. It is stated that we are to test the hypothesis, assuming this data to be normally distributed. We want to test the hypothesis or the null hypothesis that sigma is equal to sigma naught, which is 1.151. So, we have to find the value of the critical region for this value 1.151, okay, and chi-square is calculated from this value 15 into this square 1.42 by 1.151, which is the value of the sigma naught. And here I have committed a mistake. This is the value of a square, but sigma naught is this. So, there is a square which I omitted. So, this is more or less the calculation part of the problem. Now, we move on to the part of using that value to find the value of the critical region. Okay. Here, if we have a chi-square table in front of us, then we can easily find that in chi-square distribution, in case of degrees of freedom given by 14 and at 5% significance level, we have the value of chi-square as 23.6848. This is the table of chi-square distribution, and this is n is 14 and here is the. So, if we match them up for n 14, we have 23.68 at 0.05. So, we can easily write that the critical region is 23.68. So, the main task is to find the critical region from the chi-square table using the degrees of freedom n equal to 14 at 5% level. I hope I have been able to make you understand. And this value is okay. So, we are to calculate chi-square in this case only. What is the value of chi-square in this case? We can easily find, and if that value is not greater than 23.68, we can easily say that we accept H naught, that is the population standard deviation is not greater than sigma naught 1.151. So, that is one type of test of hypothesis problem.